Hello students, today we're going to study some new topics, new algorithms, mostly classification algorithms. So here today we're going to study cover three topics, such as decision tree, key nearest neighborhoods or KNN, support vector machine, and we're going to talk about the concepts, strengths, and the weakness for each algorithm. So decision tree is a rule-based machine learning algorithm, and this decision tree algorithm used in many aspects in our daily life, in some IT companies. So decision tree has three kind of structure. So as you can see, it has a root node and it has branches, and these branches can be traversed based on some conditions. So for example, let's say you have some job offer, and you need to decide, will you accept this offer or will you decline? So let's say some company offering you like $50,000 per year, and if it's more than, for example, $50,000, then you accept this job offer, but you have some other conditions in your mind. But if first condition is not met, you'll decline this job offer. You decline this job offer. But if yes, you might ask another question. For example, if you commute more than 1 hour, if yes, you will decline this job offer. But if no, you have some other question in your mind, which is, does this company, for example, offer free coffee? It's of course not that much important, but for you maybe it's important. So if company offers free coffee, then you definitely accept this offer. If it's not, you decline this offer. So as you can see, from the root node, you have some important condition in your mind, and if it's satisfied, then you go to another branch and ask another question, and if it's satisfied, then you might have you go through some other conditions, which is important to you. So as you can see, you decide, you make decisions on some conditions. So this is, as name suggests, decision tree algorithm. So let's look for this example. In this example, we need to classify, for example, we don't know about fruit itself. Let's say we don't recognize by ourselves, but maybe we recognize by ourselves, but we want to classify with some algorithm. We don't want to get involved on this process, but we want to be decided by computer. So in such case, in order to make a classification, we need to know some features of these fruits. As example, for example, color, diameter, and based on that we have some labels. So now let's build, for example, decision tree. And as you can see, here, for example, we have several different colors, green, yellow, red, and so on, different diameter size, and the label. So let's say in our first root node, we might ask ourselves, is diameter, for example, bigger than 3? If yes, then we go to another branch which satisfies condition true, and then another question we might ask, is color yellow? if color is yellow, so it's maybe for 50% confidence it's mango, or with 50% confidence it's lemon. If, for example, color is not yellow, then it's definitely, for example, diameter is bigger than 3 and color is not yellow, so maybe this is mango, yeah? So this is how decisions made. If diameter is not bigger than 3, so it's definitely, for example, 100% grape. So this is how decision tree works. So in decision tree, there is several terms, yeah, terms or some features that we need to consider. First, we have root node, yeah, root node, or sometimes it's called parent node, where your decision tree starts. So it represents entire population or sample, and this further gets divided into 2 or more homogeneous sets, yeah? So initially you have some at the beginning tree and parent node, and from that point you start to split your data set, and the other branches called like child nodes, yeah? And or it's also called like subtree, yeah, branch, where your decision tree starts to get splitted into some different smaller branches. And the branches nodes, yeah, that cannot be splitted further some other branches, it's called leaf node. And splitting is a dividing process, yeah, your samples, initial samples. So this is basic terms in decision tree, that based on what kind of conditions we can split our decision tree. So it can be based Gini index. So this is a measure of impurity, yeah, or purity of your sample. So at the beginning, it will not be pure because in decision tree you should classify your data sets into the label. So it means you have several classes in your samples. Also, there is some other conditions that you can use. It's chi-square, so it's based on statistical significance. Information gain, it's based on entropy, yeah, and the reduction in variance. So let's continue. Purity or impurity. So as you can see, we from the presentation you might see 2 baskets here. In the first basket, we have several fruits, yeah. For example, banana, apple, grapes, and some other things, yeah. But in other side, you have only apple in your basket, so it means impurity is equal to 0. In the left side, its impurity is not equal to 0 because we have different fruits like cherry, grape, banana, apple, and so on. So entropy defines randomness in the data, yeah. Entropy is measure of impurity in your sample. So we might split our dataset based on this measure. As you can see, if entropy is close to 0, it means there is no disorder. It means your sample is pure. If in your sample different classes distributed equally, so it means, for example, entropy is high, yeah. So if it's evenly distributed. So let's look here another example, yeah, where you can see now what is a root node and what is the branches and what is the leaf nodes, yeah. As you can see, we divided this, for example, we have 2 classes, which is oranges and mandarins, and there is conditions which based on these conditions is divided, yeah. First root node has, if diameter, for example, is less than 7 or not. And the second branches is based on color, yeah. So based on that, as you can see, where is the most fractions, then classes will be defined based on which one has more fractions, yeah. For example, in the list leaf on the right side of the branch, yeah, we can see, for example, orange. We have more orange, so that's why topmost left branch, right branch can be classified as oranges. In the second one, as you can see, where the diameter is bigger than 7 centimeter and the color is less than 6, most of them is mandarins. And in the other side of branch, as you can see, diameter is less than 7, but if the color is less than 5, most of them is the mandarins, and if its color is higher than 5, then it's oranges, yeah. So this is another example of decision tree implementation. So here, Gini impurity formula, as you can see, we just calculate fraction of the different classes, sum up and subtract from 1. So which gives us Gini impurity. This is a formula of how we calculate, for example, Gini impurity for the left child branch and the right child branch, and the Gini splitting impurity measure, yeah. So when we implement, for example, decision tree, so key steps when we implement in code and when we train, what kind of steps is conducted, yeah. So first, root node contains all entire training data set, yeah, and then we first provide like some features, yeah, important features to make decisions, as example of in deciding which one is the oranges or which one is the mandarins. We provide some features, yeah, like diameter, color intensity, and based on that we start to split our samples into branches, yeah, for example, based on Gini impurity measure. Then we each time we evaluate the performance of the algorithm, yeah. So it might define threshold, yeah. Threshold, this is the conditions, yeah. For example, if diameter less than, for example, 7 centimeter, this is a decision threshold. Or for example, if age is then under 30, then we group these samples into this branch and this one into this one. So this is called decision threshold. So it's each time of training, it changes, yeah. So for classification algorithm purposes, we use, for example, Gini impurity. So we recursively split our dataset until we have pure node, yeah. So so we have some stopping criterion, yeah, and once the stopping criterion is met, we finish our training process. So this is general steps in training decision tree. So here are some example of how we can calculate Gini impurity, yeah, coefficient. For example, imagine we have a data set, yeah, of two, which has samples of 2 classes, and in class 0 we have 80 samples, and the class 1 we have 20 samples. So based on that, we just calculate fraction, and then we sum up these fractions. We sum up the squares and subtract from 1, which gives us Gini impurity for the node. So for example, here how we calculate Gini impurity in this concrete example. And as you can see, Gini impurity for the left side node is 0.053, and Gini impurity for the right side is in the topmost child is 0.345. So we calculate this Gini impurity here for these child nodes, and as you can see, sum of Gini impurity is 0.11, which is less than parent node Gini impurity 0.287. So if the best weighted Gini impurity for the two child node is not lower than Gini impurity for the parent node, you should not split the parent node any further. So this is some condition where we can stop splitting. So entropy is another approach, to calculate to split our data set. So here one more example of rain prediction. If for example tomorrow will be rain, so we might use some features like humidity, minimum temperature, wind speed, and the sunshine, for example. So as you can see, class 1 corresponds if tomorrow will be rain, and the class 0 corresponds if there will not be rain. So as you can see, we always calculate Gini impurity, and we have number of samples. So samples for value represents sample for each class. So as you can see, we have first condition is if humidity is for example less than 71.5. If it's false, we check if humidity is less than, for example, 83.5, and then we check some other conditions like minimum temperature or wind speed, so such that we first divide our samples into sub samples, and we look for classes. So as you can see in the topmost lowest child node, as you can see, has class 1, so it means tomorrow then it will be rain, as a so prediction says, for example, it will be rain. So as you can see, if humidity is less than 70, if higher than 74.5, or even if it's higher than 83.5, and the minimum temperature is less than 4.65, then with more confidence tomorrow will be rain. And here another condition, if wind gas is for example higher than 45, then probably tomorrow will be rain. Otherwise there is will not be rain. And there is some other conditions. For example, if humidity is higher than less than 74.5, and there is rainfall condition, and the humidity, sunshine. So as you can see, in most cases there is classes classified as tomorrow will not be rain. So here, using decision tree, plotted prediction plane. So as you can see here, wind speed, wind speed and the humidity. So we have two features. As you can see, probability of raining tomorrow. So as you can see, as wind speed increases and the humidity is low, then there is like 30% being, or 40% being rain, yeah. But as the wind speed, for example, increase, or in any wind speed, but if humidity is high, then there is high probability of being tomorrow rain. So here this kind of prediction plane is plotted, yeah, built, and based on that given new data, it can predict if tomorrow will be rain or not. So in order to build this prediction plane, it's used this decision tree algorithm.